Hi and welcome to TRX Bench. Today here on the bench we have a Yaesu FT-DX3000 and the radio came in with a backlight problem on the frequency display. So the TFT seems to be fine, but there is a problem with the frequency display, which is totally dark, and we need to get it back up lightning. So let's have a look and let's see what we can do. Alright, and here it is. So you see here our TFT is working just fine, no problem, but our frequency display is totally dark, so it is not working at all. Well, and since the backlight intensity can be adjusted by menu, we want to see if for any reason the backlight for our frequency display may be switched off. So let's go into the menu like so. Go a bit closer that you can read it, and I have seen that it is somewhere in the beginning, and yeah, so there it is. So you see we have here dimmer VFO, and it is in preset at 8, and that is how our manual is describing it. But anyways, let's go into that menu and let's see if that will change anything. So I select now the dimmer VFO, right? And yeah, let's see when I start turning it, and you see, yeah, I can move it here, the numbers. I can really move here, so now it is switched off, and I can move it up to 15, but even on 15 we do not have our backlight. I mean, we have of course our display, so you can see it a little bit in, yeah, so you can see it, and now I can turn it, and that is a display by itself, right? But it is not our backlight illumination, and yeah, so therefore let's go back to the factory preset, which is 8, and yeah, let's see if, for instance, here our backlight, dimmer backlight is working. So we go into that. Let's see what's happened if we move that. Okay, so that is this here, right? So you see I can turn it up and down, so back to 8, which is factory preset, and let me check if we go to dimmer TFT. So let's see if that is working, and we can see it. We can change here the backlight, and yeah, let's go to preset. Fine. So that means obviously that there is really a problem with our hardware. So it is not a software setting, and that means, yeah, we have to crack open the radio and really see what's going on here with our backlight. Right, so I was able to manage it that way here, so that I get here our front panel off. And yeah, the wires are really short, so it is a little bit tricky. But as it is, I can get here access to our, is it readable? To our display 2 unit, which is mentioned down here. So that is the display 2 unit, and that is our VFO display or frequency display, however you want to call it. And well, since we know that it is display 2 unit, let's have a short look into the schematic. Alright, here it is. So that is our display 2 unit, and yeah, important is so that here is our backlight LED. So first of all, that means yeah, we are really having LEDs here for illumination. And let me zoom in here a little bit, and yeah, what we can see is that this here is the supplying transistors, if you like. So that is a kind of power transistor with a Zener diode delivering voltage to the Q7503, and then we have here another transistor, and I believe that will go down to adjust the backlight intensity. And yeah, let me see where this line is going to, and yeah, don't know if you can read it. It is called dim, so most likely for dimmer. And yeah, sure, if that transistor is not working, then we do not get a negative potential to the base, which then means we will not have current flow. So that is how it is basically working. And then yeah, so the Q7503 is finally supplying here over 3 resistors our LED block. So that is basically quite easy what we can see here. So that means where can we start? Well, so that is easy. So we see that from the pin out here we have 2 lines, 13 volt. So that will be definitely our first test. Do we have our, first of all, 13 volt, and then secondly, what's about our 5 volt, which is important as well. Is it important? No, not really for the backlight. So the 5 volt here are obviously, yeah, so that is the power supply for the processor, but we know that the display itself is working, so it is showing the VFO frequency. So that means we only need to concentrate here on our 13 volt. So let's see if the 13 volt is present. Right, so first what we do is, so I've connected ground here, and I want to know if ground is really here at the PCB. I mean, I'm sure it is, because we have our display on, so it must be there. But anyways, to make it sure, so beeper is on. So let's see. Yeah, sure. So we have ground present at our PCB, but that is what I've expected. So next step is, so here the last pin must be, let me see if I can go here a bit closer. So the last pin here seems to be our 13 volt, and I'm quite sure that it is that way. Even here is no pin out on the connector, but we have here 3 little capacitors, and these little capacitors are seen in the schematic connected to our 13 volt line, so we can directly start there. I now fire up the radio, and then let's see what we find on the pin. Right, so radio is on, so you can hear it. We have static, and now I go down to the test point we discussed earlier. So let's see what we have there. Wow, and I'm already down here. Ah, okay, so there it is. So we definitely have our 13 volt at our test point. So that means our PCB gets supplied by the needed power. Now we need to follow our schematic to see where we are losing our supply voltage. Right, our next steps will be, we are gonna test here at the collector. So there we should have, of course, our 13 volt. We want to check at the base, so that is 8.2 Zener, and that means we should read 8.2 volt here, and then we should read at the emitter approximately 8 volt, which is then supplying here our Q7503. Yeah, let's see. We should see, dependent on this transistor here, we should see here varying voltage dependent on the brightness level, which is adjusted to the radio. We should see here yeah, a DC between, I don't know, 8 volt and or 7 volt. I mean, we have a voltage drop for sure, so that means, let's say, between I don't know, 2 up to 7 volt, whatever, but a DC should be here, so that is what we want to check. Yeah, so that will be the next step, so let's see what we have. Okay, that all is not easy to see, but anyways, let's start here at our, what is it, Q7501, which is the little one here, and we should read at the collector approximately, yeah, so we have our 13 volt, that is fine. Then the base, so we have here our little Zener diode, so let me see what we have here, and 8.3, so it is a 8.2 Zener, that is fine. And that means we should see at the emitter, we should see approximately 8 volt, which we have, no problem whatsoever. Now we go over to the PNP transistor, to the emitter, and here is the emitter with 8 volt, so that is a supply voltage, that is right. And yeah, let's see what we have at the collector, because the collector should be the supply for our diodes, right? So we go down to the collector here, and yeah, as you see, I'm down at the collector and there's nothing. So that is the reason why yeah, our display is dark, so that is for sure. So that means we have here base, and there is a little transistor which is responsible for the dimmer intensity, right? So let's see what we have there. 7.2, so that is a very, very positive voltage at the base, and that means that it is definitely the potential is too high to let the transistor switch through. So let me see, I don't know if you have seen it when I am touching, so let me see if we can catch it here. So when I'm touching here the base of the power transistor, let's see. Don't know if you can see it. So here in this, can you see it? I really don't know. So let's try once again. Not sure if I can catch it here. Let's see. I try it again. Yeah, you should see it here, I believe. Watch this hole here when I go down here. So for a short while you see that the display is coming up, so it is blinking here. So that is the moment when I'm touching the base, and that means that the potential of this test point is changing a bit, and that seems to be enough for bringing up finally the more negative potential to the base and lets the transistor switching through. So that means that obviously our power transistor is fine, because otherwise I believe it would not be possible to switch it through, and for a short moment it is switching through, right? So therefore something might be wrong here with our little dimmer transistor. So that is what we need to invest right now. Right, so we have seen when I'm touching this test point with my probe, so we see for a short moment that our display is blinking, and I'm now really interested in the question, if we put this point here over 3.9 kilo ohm resistor to ground, will we then be able to get our display illumination switching on? So if that would work, then this transistor, our LED bar, everything is fine. Then we might have here a problem with our little transistor, or maybe, so we have here a 0 ohm resistor in line, so maybe that we have here a problem because we need a positive voltage from the dimmer here. Maybe that is coming from the control board, so we need to check it then. So we need a positive voltage finally to get this transistor here switching through, right? So let's see. So first let's try to pull it to ground. Right, let's do it this way. So you see I have here simply a resistor, and my wire is here to ground. And now let me go to the base of our power transistor, which is here, and let's see. And yeah, so you see we get a nice display illumination by pulling it to ground. So I'm not sure, let me double check if you can see it. Yeah, I believe you really can see it. And so that means what's going on here with our little resistor, because as I told you, we need a positive voltage at our base of the little transistor here. right? This one here. So we need some more light. So we need the positive voltage, and the positive voltage to the base should come here over this 0 ohm resistor, right? And let me see, and that is 94 millivolt, and that is definitely too low. And on the other side 94. So that means we will have most likely 90 millivolt, yeah, exactly. So we only have 90 millivolt at our base, and for sure in that case our transistor can't switch through and can't illuminate our backlight, right? Right, now we do it exactly the other way round. So I use here my power supply, and I have here one K resistor at the top, right? And now we go down to the base of our little dimmer transistor, and let's see if we give a positive voltage to the base, of course over our 1 kilo ohm resistor, and let's see if that will then switch on the backlight. Right, everything is nice and dark, and now let's go down here to the base and let's see. Yeah, so we see it is switched on. Right, so what I've done, I put over a 1K resistor right here at the base, 5 volt, and then we have seen our LED bar was switching on. And guys, to be honest, that is now more complicated as we had it before. So I was really hoping that one of these transistors, or maybe even here the LED bar, or maybe our little 0 ohm bridge, this guy here was maybe open, but no, it is not. So the entire circuitry here on this PCB is working just fine. So the dim line here is not bringing up our, I don't know, if it is really 5 volt, but anyways, we need a positive voltage from the control board, or wherever it's coming from. We need to check it right now, and yeah. Let's see where we get our positive voltage delivered from, and why it is not coming up, because that is a problem, not the display board here. I've taken off the button lid here, and now we have access to the control board. So the control board is here underneath this, don't know what's in there, but yeah, we need to get finally here down below to get down to, yeah, whatever it is. So we need to go to check it out in our circuitry, in our schematic, where our analog positive signal is coming from, but most likely control board. So let's check that. A good approach is always here over our connection diagram, and when we enlarge it here, so we find here our display 2 unit, which we were working on, and of course we see that we have here our DIM 1 input, which is here, right? Now we need to follow here the wire, and we see that the DIM 1 here is going obviously here over, what is it? Okay, so that is the switch A unit, And I really believe that somehow it is then going over to a control unit. So let's see where so here we have, as you can see, two control unit, and yeah, let's see if we find here again. Yeah, look here. So there we have our DIM 1 and DIM 2. So let me enlarge it. There is our DIM 1 port, and as I said, that is going over to control board. So we follow over here the wire harness over to the control board. So switch A unit, it is here, and again on the control board there we have our DIM 1. So let's go over to the control unit, and let's see where this DIM 1 is coming from. Here we have our control unit, and let's zoom in. And on the control board zoomed in, we find here again our DIM 1 connector, which is going here into this distributor. And now we need, of course, to follow the distributor here, and that is sometimes not very easy. So I just checked it out where it is really going to, and well, let's see where it ends up. And here we have it, our Q3052, which is a digital analog converter, right? We find DIM 1 and DIM 2. So at pin 9 of the IC, we should see a positive voltage depending on what the setting is over the menu. So you remember it is on a factory setting, which was on step 8, and that means corresponding to 8 we need here a positive voltage. And the beauty is that we can check here on pin 2, because that is DIM 2, we can check what the voltage will be here, and what we can check as well. So we can go into the menu and can see if we can change the voltage at both of these dimmer outputs. And that's what we want to do. So look and find the Q3052, and then we can go down and probe it. Right, and I've taken here this PCB, this shielded PCB out of the way. I mean, yeah, we have here a ribbon wire, so we only can put it in this position, but that is fine, so no problem. Now we really have access to our Q3055, which is this one down here. So let me zoom in, and what we can see here, that is our DC digital analog converter. And yeah, let's probe down there. I mean, radio is switched on, so we can hear the static. Now let me change here a little bit the camera position, and then let's see what we have at our test points. Right, so I hope now you can see everything we need, and let me go down to the test point. No, that was not the right one. So that is the right one, 2.3 volt, which is fine. And now let's test the second one, our DIM 2, and that is 2.4 as well. So that means that our voltage, our DC voltage is definitely present at our IC, which is finally very good news, since we know that our IC is working. So what we then have is only the wiring in between. I mean, in between from the control board towards or over the control A board, or what was it called? Let me switch to the switch A unit. Over the switch A unit, and then over to our display 2 board. So there's a lot of wiring in between, but nothing else, nothing special. So that must hang together with, yeah, finally the wiring, because there is nothing else. So let's see here on our control board where we find the connector which is going over to the switch A unit. Right, so that is the first connector which we need to check. So don't know if we can read it down there. So there you see switch A unit. So that is really going over to the switch A unit. So let me take out here the ribbon cable, and let's check this connector here, and then let's see how we proceed. Right, and as you can see, I have this ribbon cable out, and now we want to bring it back into the connector. And well, I have checked here the connector with the microscope, and I found a connection that looked a little bit, it was not completely clear if it is wrong or not, so I put my soldering iron onto it and I reflowed it. Not sure if that was a problem, but it looked a little bit funny, so I decided, come on, that is no problem, let me simply reflow it, and then we will see. So everything else is now back in place. Let's try. Okay, so let's see. Radio is connected back to our power supply. So let's see what we have. Ah, come on! Hey, have a look! It's it's back! So that was really unexpected. So that means that really the funny solder point was, yeah, not really connecting to the PCB, and but really I didn't believe that that was a problem. Because otherwise I would have shown it to you. I really thought, okay, but hey, that was really the problem. So that is, I really can't believe it. So you see, still here our microscope is in position to check it, and really, so I didn't believe that. So let me go here into the circuit once again, and it is this connector here. And now when I wiggle it here a little bit, now it is stable. So for sure for sure that was obviously the problem. Yeah, so I mean, you know, it was not so easy to find, since you have seen we have tested the whole circuit, both on the display 2 unit and here on the control board, and all the tests we have done was positive. So that means we were not able to find a fault, right? So, and simply by removing here our ribbon cable and one point with which was looking a little bit dodgy, which I soldered once again, reflowed once again, seems to be the solder point which made not really a contact to the PCB. So call it lucky to really found this solder point, because, you know, yeah, you easily can oversee something like that. Okay, so let's check again. We switch it on. As you see, it comes directly up. So very nice, no problem. But now I'm interested if we are able to change the intensity. So what is it here? Dimmer VFO. Select, and now have a look. So it is now working very nice. So that is 15 and it was set to 8. So that is what we have checked in the beginning, that all are preset to step 8, and you see we really are able to put it like we want. And yeah, so that means that was successful. Really, guys, I didn't expect that it was exactly that connection. So I really didn't expect that. So normally you really have a nightmare with finding where you lose your connection. And it is really not seldom that you know, a connection is going bad over a PCB through a VR or what have we, you know. So it is always a nightmare. Also, you know, it is only a connection from one point to the other, and sometimes you simply need to put a bridge wire between these both points to have it back working. But this was really unexpected, and yeah, I'm really happy that it turned out this way. So that means sometimes you simply need to be lucky, and that is what we have here. And of course that means that we are already at the end of our video. So let's see if everything is working fine. So no doubt, yeah, job is done. So we stop here. Thanks for watching. Hope you learned something. And sometimes, yeah, sometimes we are simply lucky. And that is what we were here. And yeah, catch you next time. Bye.